Welcome back. Up next is Mike Costa. Mike is the Principal Vice President and General Manager for Defense and Space at Bechtel Corporation. Michael joined Bechtel in 2011 as a manager of corporate quality and Six Sigma. Prior to joining Bechtel, he spent 25 years in the defense and space industry, working for leading companies such as Boeing, Rockwell, and Raytheon. We have at least one Raytheon YP here with us this afternoon. His complete bio can be found in your app, and he is going to tell us about a fascinating project that has workforce challenges, a mega project for sure, a lot of technology, and it's quite interesting to see how they're moving along on this very spectacular project. Will you welcome Mike Costa? Thank you so much.
Thank you, Greg.
With us.
Appreciate it. All right. Hey, Greg and Jim, thank you for having us here. You guys run a first-class outfit, so we appreciate all that you do for this crowd. I get a great opportunity to talk about the Mobile Launcher 2 project, a job that we execute for NASA down at Kennedy Space Flight Center. And let me see if I could, you guys might need to help me get to my first slide here. All right, we'll just set it up. A lot of great projects are being led by construction teams here in this meeting, and also by your clients. And so we're really humbled to have the ability to come in here and talk about this project. It is absolutely a special job. And you guys could help me get to my first slide. We'll get this thing rolling. There we go. Okay, so great picture there, Kennedy Space Flight Center. I'm sure there's a lot of folks that have had the opportunity to make it to the Cape. We're pretty fortunate. We're there every day. This is a picture here of what we call the park site, right next to the vehicle assembly building, a building that's almost 600 feet tall, probably one of the tallest buildings in the state of Florida. We've got about 400 souls that are there executing the job for us every day, grinding it out. It's a tough one. We've come through engineering, and now we're getting heavy into the construction work. Let me set it up by first talking a little bit about the Artemis campaign. I think, how many of you folks saw the Artemis 1 launch? All right. You see SpaceX launches all the time because they launch every 2 hours. It's amazing. Artemis 1 was the first launch of the Space Launch System. There's this big focus on deep space exploration, and the Artemis program it's basically synonymous almost with the Apollo program. The Artemis Accords are basically nation countries that have come together and collaborating on this program, much like we saw in the shuttle program. But in this particular case, we have at least 33, if not 34 countries that have come together to make this program successful. It's led, of course, by the United States of America, and we're really focused on colonizing the moon and then being off to Mars after that, and beating the Chinese there by 2030. Artemis 1 was launched in November of 2022. There was some recent press that just recently came out on Artemis 2 and Artemis 3 getting pushed a bit because they're focused right now on some flight safety issues that they need to get resolved before they start launching humans, which will be on the next vehicle. If you were to look at, now I'm going to show you the two launch platforms, at least for the first 3 missions, Mobile Launcher 1 will carry the load, and then the remaining missions will go off of ML2. If you look at all the space system elements across NASA's SLS program, we work with the NASA Exploration Ground Systems customer, and so we just focus specifically on the ground infrastructure. The Space Launch System is the rocket and everything that goes into the rocket, and Orion is a product that basically the capsule that contains human life for every one of the launches. Gateway will be orbiting the moon, and that's basically the the point at which Orion will dock with Gateway, and then folks will basically transition from Gateway to the lunar surface. There'll be at least 2 different lunar landers that are in development right now, and then of course there's a big thing about spacesuits these days. They want the spacesuits to be really sexy looking. Go figure. I'd rather it be functional, but a lot of effort's going into spacesuits. But we work for EGS. They're a great customer to work with, and they do really tough things. So let's talk about the mobile launchers. Why it's mobile. There's this thing called a crawler that was built back in the 60s for the Apollo program. It's a large tracked vehicle like you see there. There's 2 of them, and those crawlers basically carry the entire kit. The launch platform, the vehicle, everything that goes along with it. Takes it on a ride from the vehicle assembly building at about a pace of, I think it's 1 mile per hour, pretty slow. And basically goes up the hill, sets it in place on the launch pad, and then everything's ready to go. This gets back to the point that I made before. Those first 2 vehicles that you see on the slide on the left, those are essentially the kind of the flight test vehicles that are going to take humans first to orbit the moon, and then they're going to land humans on the moon on Artemis 3. Then Artemis 4 and beyond, that's all the payloads, the major payloads, and the larger crews that will essentially inhabit the Gateway and also set up our moon base on the lunar surface. So we're focused right now on ML2, and those are the missions that justify our having a new launch platform. On the left, you see Mobile Launcher 1, and then to the right-hand side, Launcher 2. Because of the size of the launch vehicle, ML2 is more structurally stout. It's about 40 feet by 50 feet wide versus 40 by 40 on the existing launch platform. The existing launch platform was basically a launch pad that was developed for the shuttle program. Then it got converted over to the Constellation program, and then it got repurposed over to SLS. Everything that we're doing, if you were to look at our launch platform, it's 110% greenfield project with all the enhancements that are necessary to support this flight and all the future flights, but at the same time to overcome the maintenance and sustainability challenges that they had on the prior launch vehicle, and launch platform, I should say. ML1 was about 10 million pounds. ML2 is about 12.5 million pounds. And I'll explain in a second why that's important. From ground level, it's about 402 feet high. So, when you're talking about safety for your crews, how you plan for safety, how you ensure that when people come to work every day, they get home to their loved ones in the best way possible. Working at elevation, as we all know, is a real challenge. And so we're doing a lot of things right now to prevent that from happening. So it's not an ordinary construction project. If you look at the ML, I had mentioned before, there's several sites across Kennedy Space Flight Center where we do the work. And kind of at you could see right in the center top, the vehicle assembly building. That'll kind of give you a good reference point. Next to the vehicle assembly building, we've got a dock. So all of our steel comes on barge. To that dock, it goes to our coatings facility. So basically what we did was utilize an existing slab surface and created a large coatings facility. So as soon as we get our steel there, we prep it up, coat it, and it goes right over to what we call the park site, where we basically start assembling the steel for the base structure. PCC building that's our project office, so we're co-located with our NASA customer, and then just a short drive to the construction site. We have a module yard. That'll be important when I show you the workflow because we got 2 critical paths through the base and also through all the modules, and so that mod yard's pretty close to the old NASA headquarters building. It's actually a great area for doing module fab. And then next to that, we have a large laydown yard, probably one of our most sophisticated laydown yards in the company. It's all asphalt former parking lot, and it works out really well for us, especially in the rainy season. We should be wrapping the job up around mid-2026, and it's a big contract, cost plus award fee. Like I said, we've got about 400 folks on the job, 450 craft at peak, and represented by 7 local unions, all of which we've got a great relationship with. This is a job that, if we were to look at it, it's a structure that goes through extreme everything. Blast loads from launch, you know, the cryogenics that go to those 4 RS-25 engines on the bottom of the launch vehicle, they're plumbed from large storage tanks, liquid hydrogen, liquid oxygen, temperatures at about negative 423. At the flame holes between the RS-25s and the 2 solid rocket motors, those temperatures range anywhere between 2,000 and 3,000 F. And so while you're generating all that heat and those blast loads, you're throwing a ton of water on that launch platform. So those materials are going through a tremendous amount of extremes. 35 stories tall, and just, you know, as I noted before, the dimensions of the tower specifically hold up through all of the effects of launch. Not to mention that when you're next to the Atlantic Ocean, you're dealing with a whole ton of salt water in the air, which impinge upon the kind of materials that we built a launch platform with. How many of you in the construction industry here have designed and built projects and optimized the weight of your projects? Anybody? There's a couple hands here. I want to talk to you guys about your experience on it. This is really interesting because the crawler way that you take the whole launch vehicle and the stack to the launch pad with is weight limited. And so if your crawler plus the weight of the launch platform plus the weight of the launch vehicle exceeds a certain threshold, that's a really bad day for the program. So this chart that we have here, through every single phase of the design, we had to model it for weight. And so you design something and you're like, hey, great, we got a tower that's structurally fit for purpose. And then you look at it and you say, hey, we ran the weight model and it's way too heavy. Well, you go back to the drawing board and figure it out. And that's what our design teams had to do. So they've managed to do a really good job of building the ML within the weight limits. But at the same time, every single step of the construction process, from engineered equipment to the commodities that we're installing, to the weight of the entire structure in itself, it's constantly verified on load cells and tracked through the entire process. Pretty amazing. The other thing that we have to do, and if you look at the crew access arm, the vehicle dampener, and the vehicle stabilizer, all of which are important structures that mount to the tower, we actually have to, before those are installed, build the tower so it's got a lean in it, so we can make the tolerances, which are about down to the 1/8 of an inch, from a positional tolerancing standpoint, just to make sure that everything lines up to the launch vehicle in the best way possible. So it's really interesting how our designers had to kind of think through where they can accommodate the lean that they need to make these interfaces work for us. So crew access arm, you need that to get the crew to the vehicle. The vehicle dampener is used basically to take the vehicle to the launch site in transportation mode, and then the vehicle stabilizers there on launch day, just to make sure that once you light it up, everything's heading in the right direction. We do have an emergency crew egress system. This is it's a pretty wild ride, about 317 feet from the crew level all the way down to the base of the launch platform. If you have to, for whatever reason, due to an emergency condition, you jump into this basket with the rest of your crew, and you head down that guide wire pretty quick. So you get down to the bottom, you get into a half track, and you take the half track somewhere to get more or less into a safe zone. And this gets back to the point that I made before: confined spaces, tripping hazards, designing for crew access. We did a lot of work to try to take the elevator. The elevator runs the entire length of the launch platform, but we wanted to put that in a location where our piping runs were straight. More bends leads to complexity, and we wanted to try to eliminate as much welding and things like that as possible, so we have straight piping runs. And then we ended up putting the elevator shaft in a section that opens up the majority of the launch platform modules for maintainability, because there's, I think we have some Jacobs team members in here. They're the contractor, the Comet contractor contract that maintain the ML from flight to flight. And so we really put a lot of effort to think that through. Human factors was a huge part of what we did to design this in such a way that people could do their work on the launch platform safely. Safety. There's been a lot of discussions here about the things that we need to do to keep our team members safe. And so early on in the design cycle, we design for safety in everything that we do. When we build our modules, the modules are fully stuffed with equipment and commodities, and then all of our safety apparatus are installed on the modules. So when we SPMT the modules over to the park site, we lift them up, put them in place, and we give our people the best opportunity for success, so they're not in a situation where they're being put in harm's way. So we spend a lot of time working directly with our NASA customer, not only talking about how we're executing the work, but every single day how important it is that everybody that gains access to that launch platform knows precisely what our work rules are. And the gentleman that's there in the black is our NASA customer. The gentleman to our left is our PM on the job. And they literally meet every single day to talk about all elements of the program, but we've done a really good job of making sure that all of our people have the skills that they need to perform work here. Talking about those skills, we have a hazard school. It's on site within walking distance of the platform. And everything about the risks that we have relating to this specific job that have either been identified by the craft and our superintendents, right down to our job hazards analysis, guide us through this hazard school. And we do this on all of our jobs, of course. This one's specifically tailored for the kind of work that we do on ML2. This job is it's a little bit different than most. NASA customer, and just through my past aerospace experience, they like doing construction projects, but they like to do aerospace-like things. So it's really the two coming together. So we've got a strong systems engineering team and chief engineer on our team that zippers up with their chief engineer. There's a whole bunch of government furnished elements where they design certain things, we'll procure them, we'll get them built within the supply base, and then we're back at the construction site integrating their designed hardware into the platform. We're integrated into the critical design review process that NASA has for all of their elements. And so when we go to those reviews, we have our content that we have to present. If there are any impacts to our design, we're raising our hand and saying, hey, this is going to be a problem, you guys. And we just kind of hammer through it. And then all of our business systems are integrated together, and this is a earned value management program. So that in itself is pretty interesting. A lot of discipline goes into our certified government accounting and earned value management system, but it's compliant and doing all the things that we need to do to not only be compliant with our contract, but also meet the government's requirements. So on the EPC side, if you were to look at the tower. So the tower is basically there's a trapezoidal section that you see in the bottom of the launch platform all the way up. There's 7 tower modules that we're building in the module yard right now. The chair is the kind of a stick-built section that's in between, and then the base is basically what's in construction right now at the site. Throughout the entire facility, there's these climate-controlled E-rooms, and really important to be able to operate all the equipment on the ML. Let's face it, when that thing it's stuffed with equipment, and it's just not a bunch of steel there. There's a lot of stuff that goes inside of it just to manage the health of the launch vehicle. You remember, this is a human spaceflight rated system, so there's the part that relates to fueling the launch vehicle and making sure that that launch vehicle is ready to go, and then all the systems that are necessary to make sure that that launch vehicle and its maintenance of human life is being managed appropriately. So sensors galore in this thing, control systems, all built within that structure. Of course, I mentioned before the umbilicals, and then as a part of the CDR, there was 53 systems that we had to specifically focus on from a design standpoint. And as you could imagine, those are flight-critical systems that NASA was constantly working with us on just to make sure that our design reviews took into account all their feedback. Pretty complex from an integration standpoint. Innovations that we've implemented, CAS Connects, there's an outfit in Brazil that we work with on this. We're really focused not only on reducing weight, but implementing these modes that basically combine to some degree welding and a bolt-together design. It's really kind of an elegant solution that's helped us streamline our execution in the field and improve our unit rates, and so that's good. Advanced work packaging, I mean, I know we're all doing it, but data-centric integration is what it's all about. And so we, at Bechtel, when we execute our jobs, our construction teams are working up front with engineering and procurement to make sure that they're getting everything that they need and their considerations are being tended to. And so our advanced work packaging system allows us to basically work directly with construction on how they want to establish the workflow and package the work for execution, and we're constantly measuring our performance across all of those packages to ensure that they've got the things that they need on time. Tools in the workplace, base camps like what you see on the top right-hand side, data vaults. We have basically portals all over the place, all over the construction site, where we're driving electronic information to the people that need it when they need it. It's really impressive what they've done. I'm going to call out our field engineering team, and one of our engineers in particular, Alex. She's amazing in the work that she's done there, and she's helped along with that construction team to make sure that all these capabilities are in place, and spent a lot of time kind of working on building capabilities and tools within a sandbox to smoke out the risks and issues that we would have with it before we got into construction. We've done that, and now we're in the field executing. Push to talk, all our GFs and our foremen and our superintendents are constantly tied in with one another through the communication system that we have on the site. When you think about it, you could start out at Brass Alley, you could start out over the construction trailers, and then you have somebody that's working at elevation, level 270, and so comms are key, right? Being able to know where everybody's at any given point in time. So a communications network that's been built around the job is critical. LiDAR scanning, I think I saw in the agenda, there's a subject on laser scanning. I love this stuff. It's amazing what we can do now with technology just to make sure that as we're building it, we've got all the quality controls in place and that we've got the positional tolerancing right before we go into the next package. And so constantly daily surveys of everything that we've built. And of course, we do the same thing in our shops. A lot of our our suppliers are out building some pretty significant structural elements, and so we're in our shops verifying everything that they give us, make sure that the paperwork is right. Have you guys ever had any issues with paperwork? Yes? Yeah. Make sure the paperwork's right before you ship. And so we're not in a situation where we're encumbered when we get in the field. We want to make sure that we're serving our construction teams in the best way possible. Oops, sorry about that. Mentioned the barge deliveries. Great having a dock right next to your construction site. I mean, I think that's a luxury. But they deliver right there, offload into the coatings yard. The coatings facility is run by a subcontractor of ours. They do just phenomenal work, you guys. Always pick the right subcontractor, right? Things work out for you. They do a great job. High quality work. We worked up front with NASA to make sure that their process was qualified. That's the other thing. Be transparent with your customer. Bring them in. Have them work with us. And we'll work with their labs. Everything's qualified, good to go. Follow the same process over and over again. That's how you get high quality stuff. Here's the two critical paths I had mentioned before, the base assembly and then the tower module assemblies. You could see 7 modules, boom, 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 boom. Those feed the critical path. Again, those modules have to be fully stuffed with equipment and commodities, ready to go when we start stacking this thing up. If it's not, then you're in a situation where later on you got to fly a piece of equipment in, and that's not very efficient. And then it's out of position work too, and it's not very safe. And so the base, as you can see, is it's in fab now. Every single time where you see something in light green on the bottom, that's basically the lift and pick moves that we have, specifically as we build the launch platform. So this picture, I think, was taken a couple of weeks ago, lifting and placing some large truss assemblies. We did something really interesting with this, and rather than building the entire base on top of the mount mechanisms that are they've been there actually for many years, the Kennedy Space Flight Center, we built the base about 8 feet off the ground. That's another part of our safety plan. We're trying to keep people off of working at extreme elevations. It's just a lot easier to work closer to the ground. And what you'll see in the video that I have in here is that in May, we'll take the crawler, roll the crawler underneath the base. The crawler will lift it up, place it on the permanent mount mechanisms where we do all of our final measurements and make sure that everything's trued up and plumb before we start adding more significant steel in place. That's called the jack and set milestone, and you'll probably see some press on that coming up. Tower module, this is module number 4, and you could see, actually it was pretty amazing how quickly that came together, and our steel fab shops did a great job of giving us high quality steel. The Cast Connect system's working really well for us, and again, we're each of these modules, we're in the module yard, not at level 270 or something like that, with folks all harnessed in and having to do things at extreme elevations. So, good work. Last time I checked, Kennedy Space Flight Center, that part of Florida, they get a lot of lightning strikes and a lot of rain. And so we've got this system that's been implemented where we can do work in really bad weather conditions. One of the things that we look at, of course, when we bid on a job is how many available days do you have for having constructive work? And a lot of lightning strikes in that area. So all of those covers that we have in place are lightning protected. So that's really helped us protect not only our people from the events of weather, but also get more productive time into our construction cycle. And okay, so this is kind of a synchro model of the work And that's what it's going to look like in probably around June of 2025. And I'm going to click this, and it'll kind of show you the fab sequence. The video is a little slow. I apologize for that. We'll probably have the ML commission by the time this is over, but I hope not. But while you're watching this, I'll probably just take you through a part of this, but I'll just make some comments about, when you look at this, this is a model, and we like these great tools and capabilities that we provide our team members. But in this particular case, I always think about, the people that we're putting in harm's way for this kind of work. Let's face it, it's an industrial area that has lots of hazards. And so we've been putting a lot of time into really thinking through how we protect our team members, both their physical and their emotional safety. I think there's a subject that's tomorrow where they're going to talk a little bit more about the emotional safety of our team members. Very, very important that our industry really takes this subject on. Had a couple issues where in this sequence, and I think it's coming up, where we had some steel shortages that we had to work through. Again, when you have those kinds of issues, it impacts your team, and you have to do workarounds. You'll see the permanent mount mechanisms. There's 6 of them. The crawler will come in here pretty fast, probably the fastest part of this video, and lift it up and place it on top of the mounts. And once that's done, you got all your equipment in the base, and it's completely skinned in. Then you start stick building what we call the chair on top of it. It's just getting ready for that. Once the chair's in place, then you have all your crane picks for the modules. So now it's getting skinned in or weathered in. A lot of commodities inside that base. And has anybody ever been in one of these launch platforms before? Well, if you're ever out in Florida, I could have our guys give you a tour. That's pretty impressive. There you go. You see basically the trapezoid and the chairs going up. Where it's light blue in the center there, that's the flame hole. So you got 4 RS-25 engines. That's really the business end of the launch vehicle, and 2 solid rocket motors. A lot of heat in there. There's these 2 stanchions. They're called rainbirds, and you'll see it during launch. They just flood that entire area with water, just to deal with the effects of the launch loads. Modules start to show up into this year, and you could see their crane pick and place away, and just boom, 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 boom. Everything's got all of its safety apparatus in place. No shortages. Just keep on telling the team, no shortages. Package it right, and you'll finish up the job within the time that's been allotted. So that's what it looks like when we wrap it up. Turning it over to NASA, and this is my last slide, so we could open up for questions. They do cold shock testing, so fill up the LH2 and liquid oxygen tanks and start sending propellants inside the ML. Basically, everything's blinded off, and then you're just checking all your cryo systems and make sure that they're operational. Instrumentation, you have multiple sets of instrumentation on this launch vehicle, just to study the health of the launch vehicle and the people on board, just to make sure that all of those different sensors are operating properly. So a lot of time goes into making sure that instrumentation is ready to go. And then when we get the vehicle in place, constantly working on the interface between the vehicle and the launcher, and make sure that everything's talking to one another. So pretty cool stuff. Our startup and commissioning teams, we always start with having our startup team members, just like construction, on the job early, thinking through just how we're planning for the turnover work, and they're really talented people, sharp and we want them there early. And so, one team, one mission, Moon to Mars. We can do this. This is what makes our country great. Okay, that's it.